Well, we've actually had a request to look at the DNT M40 again. So it happens I bought one in a pile of Tatsum probably a couple of years back. So it's got no channel knob, and it's got a short stub power lead, which we will need to sort out if we get this to work. So I need to take what remaining screws are out and pray that it hasn't been modified, because some of these got converted into 10-metre amateur sets, mostly with no success. So there's many a wrecked radio out there. So at the time I thought these were dreadful, but judging by today's sets as I record this in 2021, these aren't that bad. Now that's got a crystal filter in there, and you never know whether they've done the termination of that correctly or not. This doesn't say anywhere that it's a super tuned version, in which case that would be a kind of standard modification. The super tuned version, which normally has a green super tuned sticker on the top there, they were bulk modified by Cleartone, who are business radio people who specialise really in police things these days. So they did know what they were doing, and it was a good modification, and the sets did work well after that was done. But I don't know what state this one's going to be in. So we're going to go through everything on this. One of the things about these radios is to have a general purpose synthesizer, the MC145-106P from Motorola. So instead of it being double ROM locked like the LC7136, LC7137 from Sanyo or the Toshiba TC9119, these are not like that, and it's general purpose. You have a triple crystal mixer. So we start off, I can't remember which way round this is, but you start off with setting 10.24. So we have to do that with a frequency counter before we do anything else. And then I think one of these is going to be transmit, of course. Let's guess it's that one. And then the other one is receive. So you set the 10.24, you then set the transmit frequency, and then you set the receive frequency with a marker oscillator at 10.695 or at 0.455. So you're subtracting the IF, and then you're going to net that onto frequency with a signal generator and a marker oscillator, or with two signal generators. And I'm also going to try and go through the VCO a bit, because this is why I've been requested to have a look at one of these a second time. I don't think I can see any horrors in there. So apart from that crystal filter, there's clearly some soldering around this section, so they might have done something. But the proof of the pudding's in the eating, and if we get the right kind of sensitivity on this in test, well, we don't need to worry any further as to what somebody else has done. If we don't get the right sensitivity, it's happened a few sets back with somebody had crystal filtered something that had to come out and be I think it was an Amstrad, had to have the ceramic filter installed, which it should have been in the first place. I can see a slightly distressed capacitor there, but nothing else. That's distressed. That could be heat damage. So there's a possibility of changing a couple of capacitors too. So we'll see how it performs. The first thing we're going to have to do is to make up a microphone. I don't think we've got a DNT microphone on the bench. It's a weird pin out. That could be a Maxon mic. You know what, we will try that. You never know, we've got a 5-pin DIN on the end. So we'll find our famous crocodile clip leads. Switch on the power supply. The radio is drawing 180 milliamps. So we'll pop the test equipment into the aero socket. And we'll put the extension speaker into the instruments. That sounds pretty awful. And see what happens when we plug this mic in, which could well be Max on. Yeah, well, it certainly doesn't key up, so that isn't going to be right. Let's see if there's another one on here with the 5 pinned in. You never know. No, we'll make one up. So I'm going to pause the video and we'll make up a mic. Okay, so we'll go back into record. I've done the mic, well, I've nearly done the mic, just to show you on these. So if we're looking at it, we're looking at the mic plug. Which is 5 pinned in. And there's strange pin numbers. 2's in the middle. I can never remember which is 1 and 3. Is this labelled? Immaterial. I wonder if it's shown on my chart. Oh yes, it is. 3, 1, 4, 5. This, what it was is, these were DIN audio connectors. You know, audio was mono, and it was, I forget which way round it was, but one's record and one's playback for tape recorders. So 2's the earth, and 1's something like playback, and 3's something like record. But when stereo came along, the right hand channel was crammed in pins 4 and 5. So when there were 3 pinned in plugs, it was 1, 2 and 3. So stereo came along, added pins 4 and 5, and that's why it's a funny format. So on a DNT, and LCLs are different. On a DNT, it's 3 wires. You don't need the receive because it's got a relay in the set for receive. So you've got TX, which is, in my case, it's the red wire on these type of mics. And then 1 is common, which is the braid. And then the TX audio is, in this case, the yellow one. You always know which the TX audio one is. It's the coloured, it's the wire that's lapped with the screen. The screen doesn't go around all the wires, it just goes around the audio one. So you always know which the audio one is because it's the one wrapped by the screen. So normally you tend to find it is red for transmit and black for receive, like it is on these mics. So we'll put that together. Oh, don't have crimping things, I'll just get the pliers around that. Right, that's not going anywhere. And screw that together. These are these Rian plugs, which are quite expensive, but I really don't like those plastic ones. So you either seem to go from the 25 pence plugs to the £2.99 plugs. At least I remember to put the boot on and not do a nice wiring job and then find that you've forgotten to put the plug back on. So that should work. It's now going into transmit, but it doesn't transmit. Something's microphonic. I don't know why the cover of the relay's off. There must be somebody out there who collects relay covers. So I've done a chart. There's no guarantee we can even fix this, but we'll certainly give it a go. So you can hear it's receiving. It is crummy. It is. It's got the sensitivity. That's 3 microhertz. Can you hear off frequency that sounds? Let's just tune around. So it's never on frequency. So the actual radio is internally off frequency, which it can easily be. So that's 3 microvolts and it sounds crummy. We can hear down to about 2 microvolts. So on transmit, we don't know what it's doing because it doesn't transmit. Well, the first thing we have to do with these is to put the 10.24 crystal on frequency. You cannot do anything until you do that. So on my chart here, I've marked it yellow because it affects transmit and receive. I've marked the receive ones green and the red ones, of course, for transmit, including the meter, the deviation. The transmit VCO is 6, the receive VCO is L18. The monitor pin for the phase lock loop lock detector is pin 8. So it's an 18 pin chip. So well, I'm looking at the wrong chip. What a fool. So the ident pip is at the bottom nearest the channel selector. And so the pin 1 is always this side of the ident. So we've got the ident pip there. So that is going to be pin 1. So that's pin 18. So pin 8 is next to the end 1 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 10, 11, 12, 13, 14, 15, 16, 17, 18. That's how chips work if you don't know. So I'm just going to pause the video because I need to get the little portable oscilloscope. It makes things easier. Right, so I'm back here with the little oscilloscope. And what I've done, I've soldered a little bit of wire onto that screening cam because it's difficult to pick up an earth on these radios, so I'll do it that way. So I'm going to monitor whichever pin has got the 10.24 on it. So we know that the 10.24 crystal goes in on pin 3 and 4. So which I think it's going to be pin 4, but I could be totally lying. So if I monitor pin 4 with the oscilloscope, alright, we'll monitor pin 3 then. So we've got 10.2396. So it's not far out. Let's try and hold that with my left hand. $10.2396. Nine seven 9899 2400 10.24. Let's see if we can zoom in on that for you. And then move the camera slightly. So there we are, 10.24. So I'm on pin 4. So we'll make a note for future reference. Monitor 10.24 on pin 4 of IC3. So we know it's on frequency now on the chip. So next we're supposed to set the transmit, but it isn't transmitting. So is that the VCO that's out? So we'll turn this off. Will I get my little monitor receiver out? Let's return the camera to its normal position. So we've got our little monitor receiver on. Let's turn the squelch off. Press transmit. Testing 1 2, testing 1 2, testing 1 2. Hello, testing 1 2 1 2. I can't hear any audio. That might be another issue. 1 2 1 2 1 2 1 2. That feels like a nasty mic socket, to be honest. Bunch of nasty radios, aren't they? Testing 1 2, testing 1 2. There's something not right with the mic socket there. Testing 1 2, testing 1 2. So it is transmitting, but it's only transmitting a short distance. Chances are that it's had a bad SPR and the transistor's been ruined. So that actually means the VCO is in lock. But what we're going to do, because we're demonstrating VCO on this, it's not cut and dry like you get on the Cybernets and the Maxcoms and the Unidem based sets, where you're going to adjust something and monitor voltage. It doesn't work like that. It relies on the lock detector. So we'll pick up our earth now off there, and just for, we want pin 8, don't we, which is next to the end 1. So you can see we've got 7.38. So we'll press transmit. Now if I mess with the VCO, and I'm now going to upset the radio, which is perfectly working in that department. So the transmit VCO is L6. So let's get rid of the wax and mess with it. So monitor that, press transmit, and let's see what happens. We've got logic high at the moment, 7.36 must be logic high. So if we adjust that, it's not gone out of lock there. Let's go the other way. I'm on the wrong coil, aren't I? That's one of the transmit multipliers. Right, L6 is this one. Now, can we hear the relay chattering? It's gone out of lock. And now it's chattering the other way, it's out of lock. So the lock point is quite fine. So what we now have to do is check that it's still on lock on channel 1 and 40. And there's no transmit knob, there's no channel knob on this radio, so we'll put a big screwdriver in the slot. So I've tried to feel for the centre of the lock position. Now we're on channel 40 and it's solid lock, logic high, and now we'll put it to channel 1 and it's a solid lock, logic high. So I've got that centre position correct. But we don't know whether the thing's on frequency because we can't see it transmitting out of the test equipment at this stage. So normally I'd come to do that, but I'll tell you what we're going to do. We know the receive's in lock because we can hear it. off frequency and sounding dreadful. So once again we monitor channel 8, and this time we'll mess with L18, which is the VCO. So it's out of lock. Logic low, logic high, and again logic low. So we're in lock there, so I'm going to turn it half a turn, so nearly a full turn, not quite. So if I turn it back to there, I should be in the centre position. So once again, I'm not going to change the signal generator, but what we'll do, we'll change that channel selector switch whilst monitoring pin 8. .38 volts on channel 40 and 7.38 on channel 1. We'll go through the channels. Channel 10 and back to channel 20. So we know that both of those are in their center position. So the person having the problem with the lock, L18, which is what we're looking about on receive, L18 is somewhere around here. You've got the two mixer crystals for transmit and receive, and L18 is here. So really, all you can have wrong is that electrolytic capacitor by look. Oh, is it electrolytic? No. So you've got resistor 134 47k, that could be faulty. You've got capacitor 123, 100 picofarads. You've got capacitor 119, 47 picofarads. Resistor 132, 15k. You've got capacitor 120, 8.2 picofarads. Capacitor 122 at 30 picofarads. You could even have capacitor 18 at 15 picofarads and capacitor 12 at 82 picofarads. Resistor 131 looks like 1k to me. Resistor 133 10k. Or you could have a faulty varicap diode. But that's all you've got. 1, 2, 3, 4 resistors. 1, 2, 3, 4, 5. Even those 1, 2, 3, 4, 5, 6 capacitors at the most, and a varicap diode. So there isn't a lot which can limit the extent of the VCO. So they're the parts to look at. There's nothing else is going to cause that to play up. So I'll put the meter away. Of course, it was still attached to the. I wonder if somebody's messed about with the relay because they got no transmit. So, it surprises me that even in 2021, as I record this, an awful lot of new sets have got relays in, more than they ever did in 1981. So there you are. I thought relays were old hat in 1981, but clearly they're still putting them in. So let's look at the transmitter. It ain't transmitting. So we have a 2SC2078 as an output transistor with a 2SC2314 as a driver transistor. So we know it's transmitting because we can hear it on our monitor receiver. So it's just transmitting off its pre-driver stages. So transistor 21, not Tango 21, transistor 21. This is all out of the instruction book, which is readily downloadable. Where is it? It's that way on. I cannot see it. Oh, it's there. That's where it is, next to that coil. Right, I'm going to unsolder that little wire I put on so it doesn't get inside the works. When I press transmit, my power supply goes from 190 milliamps to 290 milliamps. I'm going to switch to low power. It's still the same. I think it's the output transistor. I could get my Russian RF millivolt meter on this, and we could find out. So I'll take the radio upside down, shorting out the power supply like usual. I wonder where all these power leads actually end up. You can see this has been changed before. It's got nothing there, nothing there. So isn't that one? Because it ain't getting there. You know what? It's not getting there either. So the fault may be earlier on in the stage, not what I was expecting at all. I'm glad you made me check. Normally the output transistor, to be honest. So if we go a stage further to transistor 22, well, actually what we can do is look at L15. And I bet that's the one next to the... It is. It's the second one along. So it's that one. So if we check what's coming out of that, nothing. Nothing. What's going into it? Nothing. Aha. So we've got RF going in, but we've got nothing coming out. So either that coil's miles out of alignment, or the secondary is open circuit. Okay, let's see what happens when we're just L15. Being careful, it's tight. monitor this with the monitor receiver. Now that transistor could be short circuit and short circuiting the output of that transformer. So we can hear that signal. I'll turn it to full volume. Not that you can hear the thing because the microphone socket's faulty. Now we're not hearing any difference. So if we play with that coil, that's the previous one. Oh, hang on a minute, it's not 18, is it, that one? Yes, it is. So it's 13, 15, that's the one to play with, 16. Nearly upset the receive. Now, I can hear that making a difference. You can hear that. But when we alter this one, we can't hear that making a difference. So I still don't know whether we've got a duff transistor there. Let's check if the transistor is getting any power. And as you can see, we transmit, we're getting, I'll move that, it is getting power to it. So either the transistor's short circuit or the coil is open circuit. Well, I think what we'll do is to take the transistor out. That's only got 3 legs, whereas the coil's got 7 with its mounting. So turn the power off. We'll unsolder the transistor and we'll check it on the transistor tester. So the shiny side, the side that could go to a heatsink, is on my left. Okay, so we've got it out. It should be 2SC2314 and it is. Well, I'll tell you what I'm going to do. I'm going to power the setup without it. Into transmit. So now, can I vary the sound we get on the monitor receiver? We're still drawing 250 milliamps. And the answer is no. I think that coil's open circuit. But we're going to prove myself a liar and test the transistor. NPN bipolar transistor. Just going to make a note on here. SC2314 gain equals 120. That's because sometimes you can end up with fake transistors, and that's this of course is a real one. Right, we'll unpower the radio once again, put the transistor back in, and I'll remove the coil. I'll do that off video. So a few days later, where are we on this set? And the answer is nowhere. I can't get the transmit to work on the one we were working on. And what I thought I'd do is to move on to another chassis. Remember, these are scrap chassis. These have been bought in as scrap chassis, and sometimes other, not just screwdriver experts, but other people who know what they're doing have looked at these and written them off. We tend to write in marker pen on them, if we scrap sets, as to what the snag is, so that they don't try and get reworked. Now, one of the problems with these sets, and has been right from the word go back in 1981, is the quality of the printed circuit boards. And double-sided boards linked through with just copper links, tinned wire. And right from these sets being new, they were problematic with dry joints between the two sides of the board. So we've still got no transmit on this one, and you've got to draw a line somewhere. And so I borrowed the relay out of it, popped the relay into this other set. And this other set said, this has been a 10-meter conversion at some time. And for those of you who know, this came from the estate of the late Harold, who ran Carlton Amateur Radio at Nottingham. And he'd written on this working but squelch problem. Well, it wasn't working because it wasn't on frequency, because there's a blown data line in the phase lock loop chip that I've taken out. We haven't got these phase lock loop chips in stock, and we haven't got any scrap chassis which have got one on. Now, here comes the thing. A lot of the time you end up with a scrap chassis or a scrap board, and this one's neatly got that corner missing, because the phase lock loop's up the spout. So I don't normally take phase lock loop chips off scrap chassis, because that's usually what the problem is. So I have ordered the MC145-106 in the hope that we can look further at this in the future. So all this video has been able to do is to hopefully show people needing to check their VCO how to do that. So we've done the 10.24, we've done the transmit and the receive VCO. That's where this video ends. We've done loads of other videos on the DNT M40, and you can also look at the DNT B40, which is the base station version, has different component values so that it works from its internal 12-volt power supply and comes with a factory-fitted crystal filter rather than a bodged wrong one. So that's where we're going to leave this, but we're not leaving it and forgetting it, because, as I say, we've got a phase lock loop chip on order, and hopefully that will sort it out. We have done so many DNT M40s since I've been doing these videos in 2014 and before I've been doing these videos, and I will say we've managed to get 4 out of 5 working again. But I've now got to those dregs where we can't really progress without spending ridiculous time and taking out loads of components and checking them individually, and of course they're just not worth it. And when we have done these, we haven't got sets of knobs. This has got the channel selector knob missing. This has got the channel selector knob missing. So even when we've done these sets, they're going to have knobs missing. And there's the late Harold's writing. OK, TX, RX, no squelch. But unfortunately, it wasn't actually on channel, and it didn't vary channel. So, you know, there was an issue, and I sorted that out as to why it wasn't changing channel. And then, blow me, the phase lock loop chip is actually up the spout. So there we are. So we'll leave it at that. I hope you found it interesting in trying to find a fault on the set, even though it hasn't worked to a fruitful end. So it's now Friday. I've really got a repair to do. We've got a York 863 which is deaf, and we really need to do that to get back to the customer. Bear in mind we've got building work here, so there's a lot of stuff in storage, and this is going to continue probably for 6 months. Once that building's finished, we've got a pipe organ to restore and install, and so there's going to be a lot of time on that. But anyway, there you go. That's the DNT M40, how not to finish one. But we've covered it so many times you can look at the back catalogue, but I had never done the VCO before, and we have done on this video. So thank you for watching, and see how we get on with the York 863.